Hey everybody, happy week 4. We are in the final stretch, so we are on to our last box. Hopefully you guys had a great weekend and you are ready to go for this week. So we are going to do our 4th and final box this week, and it is going to be our physics box. Okay, so what it is you're doing this week is you're actually going to get to build some bridges now and test them. Test the type of bridge, test the materials to see which one's the strongest. Couple of safety things for this week. I know that there's candy in here. As tempting as it is, I would suggest not eating it. Again, when you're doing a science experiment, nothing goes into your mouth. But the reasoning behind that is you're going to be putting your hands all over. You're going to be putting toothpicks and popsicle sticks and noodles and things like that in there. So you want to make sure that you're not touching or eating any of it, because it can be contaminated after putting other things into it. Also, as you're building these, obviously do it in an area that you're not going to mess anything up. And then when you're testing them, I would build them in an area, the same place that you're going to test them. That way you're not transporting them. And then finally, when you're testing them using the weights and stuff, you want to have them in an area that if they break, it's not going to break anything else around it. So, you know, a flat table, a flat surface without any breakable materials around it. So we are going to get into it. So the box that you're using is, again, your final box. It is the one with the noodles in it and the popsicle sticks and the candy and tape. It is your biggest box. So we are going to get into it. I'm going to talk about that background information, and then you guys can go ahead and do your lab. So the background information is really talking about this idea of bridges. So bridges have been around for thousands and thousands and thousands of years. They've started out very simple as natural bridges. They can be, you know, cut down or fallen trees that they've laid over things. The reason that we use bridges is to overcome obstacles, things like roads, rivers, valleys, canyons, railroad tracks are some of the main reasons. But any obstacle that requires being able to pass over is why we use bridges. So there are a lot of really, really good bridges. They have come a long way. So things like the Golden Gate Bridge, it says right in here, we have more than 500,000 in the US that are longer than 100 feet. Okay, so a lot of technology, a lot of planning, a lot of engineering goes into the construction of these bridges. And so it's important to realize that it's not just, especially for those bridges, because they have to be able to hold up under all weather conditions and all size loads and cars and different conditions. There's a lot of engineering that goes into it. And it's not just, oh, we're going to throw this bridge right here. Okay, so there's a lot of planning that goes into it. And then the other thing that goes into it is all the stuff that we've talked about up until this point. Okay, so if you're going to use electricity on it, how are you going to run it? If there's going to be lights, how are you going to construct that? The area that you're building it, so you don't disrupt habitats from last week, looking at that biology box. How can we do it so it is the least disruptive to the habitat? And then just like in our chemistry box, the corrosion level, how can we build it so it's going to withstand that weathering, so it's going to withstand trucks with heavy loads driving over it? What can we add to it that's going to be biodegradable, that's going to make it strong but not corrode? Okay, so all of those things go into that final stage of planning it and actually implementing it. And the people that really go into planning it are primarily civil and structural engineers. Okay, so they are responsible for the design of the bridge, and looking at and making those decisions of, okay, what is it actually going to look like? What materials are we actually going to use to accomplish the goal that we have for this bridge? So there are 3 main types that we're going to be talking about today. A beam, or sometimes called a truss bridge, an arch bridge, and a suspension bridge. And in your packet, there are pictures of all 3 so that you can get an idea. This would also be a good time to do a little bit of additional research on your own to figure out exactly the components of each of those bridges, because you are going to be building one of them. You are welcome to build a different type if you would like, if you do some more research and you find one that you would prefer. But it's important to understand the components of each of these bridges so that when you're building them, you have those important components that cause it to be, you know, structurally sound, or cause it to have the advantages that it does. So next we're going to talk about the types of forces that act on bridges, and why it's important to build a bridge that can withstand those forces. So you have 2 main types that act on bridges. You have compression force and a tension force, and they're kind of exactly what they sound like. So a compression force acts to compress or shorten the thing it's acting on, so causing the bridge to kind of shorten those materials to be shortened. And then you have a tension, which is a force that acts to expand or lengthen the thing it's acting on. Okay, so you have the compression that's making it shorter, and the tension that's pulling it. Okay, so as bridges sway, as cars drive over them, as they're being weathered, those are the two forces that are going into effect on that bridge. So sometimes parts are being pushed together and being compressed, and sometimes they're being pulled apart and have a tension force acting on them. So now I want to get into what exactly it is that you're going to be doing for this week. So again, take a little bit of time, do some additional research on your own on those 3 types of bridges that I just talked about and what the components are to them. What makes an arch bridge an arch? What makes a suspension bridge a suspension bridge, so that you know as you build those. So what you're going to do is your job is going to construct 3 different bridges and test the stability with weights. That's your overall goal of this. So the weights that you're going to be using is going to be steel and nail and bolts. So that's right in here. So these are going to be your weights. Okay, this is what you want your bridge to hold up to. And what you're going to do is you're going to have different materials. Now, there are a variety of ways that you can do this. If you want and you think, okay, a suspension bridge is going to be the strongest and you want to build a suspension bridge out of 3 different materials to see which material is the strongest, that's fine. If you want to use all 3 materials in one of them and build 3 different types, that's fine. Okay, but focus on one thing that you want to do, because since we're doing an experiment, you want to have one variable. So whether that be the materials are different and the types of bridge are the same, or it's the types of bridge are different and the materials are the same. But that will allow us to really test and zone in on one of those things. If you also do materials and types of bridges, you don't really know what it is that's holding up the best. You don't know if it's that type of bridge or if it's that type of material that's the strongest. So really pick one of them. Either do different types of bridges using the same materials. So maybe you're using, a combination of everything and you're going to build 3 different bridges, or do the same bridge using 3 different materials. So use the popsicle sticks to build one, the toothpicks to build another, and then the spaghetti to build another. And then you also have these candies, which you can use as the anchors or to stick the different pieces into, and you have the tape. And then additionally, if you really want to, you have the glue stick from last week that you can use as well. Okay, so what you're going to be doing is, again, building those 3 bridges. So on this sheet, it tells you that you are going to draw a sketch of those bridges. Okay, so again, decide on one of them. Okay, when we're doing an experiment, we don't want a huge or all of these different variables, so you got to make sure that you're deciding on one of them. So whether that be doing different types of bridges using the same materials, or using different materials building the same type of bridge. But whatever that case may be, you're going to pick that out. Okay, so you're going to do those research on those bridges, decide what variable it is that you want to test, and then you're going to draw a sketch of the 3 bridges that you're going to build. Okay, it just has to be a rough sketch on here, and you're going to end up taking a picture of this and submitting it to me. But so you're going to build, or you're going to draw a rough sketch of the 3 bridges. So if you decide that you're going to use an arch bridge and do different materials, you'll draw one arch bridge using popsicle sticks, one arch bridge using your spaghetti, and one arch bridge using your toothpicks. Okay, and again, make sure that you've done the research on them so that you know what components actually go into it. So as you're building it, you can make sure that you're including those. Okay, then on the next page, you're actually going to start building your bridges. So it does tell you to use a scientific method. So there are some questions at the top about the hypothesis of your bridge. So again, remember that a hypothesis is an if-then statement of what you think is going to happen. So you're going to say, if I build an arch bridge using popsicle sticks, spaghetti, and toothpicks, then the bridge built with the toothpicks is going to hold up the best against the weight, or whatever you think is going to happen. So those questions right up here, you're just going to answer. You can answer them right below here if you want, or on the back of a sheet, that's fine. But so then you're actually going to build your bridges. Okay, so this is where it's important that you did a little bit of extra research and that you know what goes into those bridges. So then you're going to take your, your materials, and you're actually going to build those 3 bridges. Once you have those bridges built, take a before picture of them. You can do 3 individual pictures, or you can again put them all in one picture and take one picture. But make sure that you're doing it somewhere that is sturdy so that you don't have to worry about transporting them. Okay. Once you have built your bridges, you are then going to test them. So you're going to take these weights and you're going to start to put them on there and see which bridge withstands the weights the most. If you want to take it one step further, if you have other things at home that weigh a little bit, you can add those on and see what one withstands the most weight. And as you do that, keep in mind those forces that we talked about, because that final question asks about the tension and compressive forces that acted on it. So where was your bridge being smushed together or being compressed, and where was it being pulled apart, having that tension on it? Okay, and you're going to answer that question as well at the bottom, and then it says draw conclusions. And so when it wants you to draw conclusions based on your observations, it wants you to determine what bridge was the best. Okay, which one withstood the most weight? And if you put the weight on them and they all withstood them, well, pay attention to, is it, leaning? Did some of the materials break? Was it a little bit more wobbly than another one? Okay, so those are some of the observations that you want to make. And so what you're going to do is that then you're going to draw, and if you want to make, you can, but you're going to draw what the best bridge that you could make would be. Okay, so if you found that the popsicle sticks withstood the most weight, you're going to draw a picture of using your popsicle sticks. And if there was a specific part that maybe in your bridge you saw where you added the weight started to dip a little bit, maybe you reinforce that a little bit more. And so you're just going to draw a final picture of what you think the best bridge would be that you could make. Okay, again, if you want to make it, go for it. But I also want you to take after pictures once you put the weight on the bridges so I can see what they looked like. Okay, so what it is that you're going to be submitting this week is, first, you're going to take a picture of this, okay, of your 3 bridge sketches, and you'll submit this. I want you to submit before and after pictures of your weights. If you want to do a video of them as you're adding the weights to them, that's great. Go for it. That would be awesome. But you don't have to. You can do just before and after pictures. So before you put the weights on of all 3 bridges, and then after you put the weights on of all 3 bridges. And then finally, a picture of this page that has these questions answered, and you can just do it, wherever there's open space. And then a picture of a drawing of your final bridge. So what the best bridge is that you can make. And again, if you want to make it, if you have the materials left to make it, go for it. You can submit that picture as well. But otherwise, that's all for the physics box. If you have any questions, as always, jump on office hours or shoot me a message on Canvas and I'll gladly answer you back. I hope that you guys had a lot of fun doing these. I know that I had a lot of fun doing them as well and making these videos for you. It was a blast. I wish I would have gotten to meet you all in person, but I've had a really fun time over the last 4 weeks working with you guys. I hope you got something out of this, and I hope that you have a great rest of summer and great school year. See ya.